Hello, checking long-term deflection in CSI SAFE. In this video, I will show you how to do a long-term deflection check in CSI SAFE. I have this model I have imported from eTabs. So what is long-term deflection? There are two types of deflection. First is the short-term deflection, sometimes called the immediate deflection, which happen in slab or any element once the load is applied. The other one is long-term deflection, which is the deformation that happens over a long period of time. So let's go straight to how you can do long-term deflection check in CSI SAFE. So of course, you need to, if you're going to model the slab here in SAFE 2016, you need to, of course, add the load patterns. So because I have imported this from eTabs, you can see there are load patterns already. Then you need to add, you need to define the load cases. You need to define new load cases. So I will add new case. Now this time it will be immediate load, immediate for all load. Don't forget to check nonlinear cracked. That is, the analysis type is nonlinear cracked. Then load case 1 is dead, scale factor is 1, live, super dead. Then okay, then we need to add a long-term sustained, add new case, long-term sustained, sustained means that, so this one is dead, superimposed, and live load. We need to reduce the scale factor for live load to 0.25. That is basically what sustained means. Now you need to make sure that the analysis type is nonlinear long-term cracked. Okay. Then we add immediate and sustained load, a new case, immediate sustained. Now the same as the first one, that is sustained or load, only this time that the live load scale factor will be 0.25. Now you must check nonlinear cracked. That is the analysis type. Okay, so dead scale factor is 1, superimposed scale factor is 1, live load, then a scale factor of 0.25, 0.25. Now, once you have defined all load cases, you can start defining a load combination. So we'll go to define, go to load combinations, add new combination. So we're going to add elastic deflection. That is a new combination, elastic deflection. just add then that is wall or superimposed, super dead, and live. Okay, add new combination. Now this time we add long term. Now this time load cases will be immediate, all. Load case 2 will be long term sustained. Load case 3 will be immediate sustained. Now the scale factor here will be -1. Now you can proceed and run the analysis. So I will uncheck and block. Let's check load combinations. Okay, now you can proceed and run the analysis. If you have noticed, I have these ones are one-way slab, one way, similar to the other duplex. And now these two slabs are two-way slabs. If also you can notice is that the analysis is taking longer than usual because of the new load cases and combination for immediate, sustained, and that is cracked or short-term deflection and long-term deflection. So let's give this a couple of minutes so that we can see the maximum value for long-term deflection, and then we will compare to our permissible limit based on the ACI code or whichever code. or either Indian, British, or American code. Well, let's see. So I'll change the units to mm, to metric default. Prefer to work with metric. Then let's go to. We need to check deflection shape for long-term combination. So display deform shape, check combination, check long-term combination. Long-term combination. Apply, then close. Well, now our maximum value is 13.43 millimeters at 6 meters and 0 meters. Now I think this point is our maximum. Our maximum deflection is at this point. All right. Okay. Now our critical panel is this one, which is about 6.2 meters by 4 meters. So to calculate our, let me remove this one. To calculate long-term reflection, permissible deflection should be equals to Ly all over 500. All right. Now Ly should be in mm. Now our Ly is about 6200 divided by 500. If you do the calculations, you get the answer to be around, let's check. The answer is around 12. Now 6200 divided by 500, that is 12.4. So the answer here is 12.4 millimeters. Now in the same panel, this one, the maximum deflection is 11.1. It means that this has passed in deflection. Now at this point, it means this point is failing in deflection. So we either need to increase the depth, because this slab is, let's check. This span is about 7 meters. This span from here to here, right, is about 7 meters. About 7 meters. If now that one will be 700, about 73 300 divided by 500. To get the answer is around 14.6. It means that this slab has passed in deflection. So this one we don't need to, because I used a depth of 400. It means if maybe we can reduce the depth of this slab. Let's reduce the depth. Edit or define. Define slab property. Slab 8 inches. Let me check. Define slab property. Modify and show property. Let's reduce this slab to 150. This is slab to 150. Now this one 6 inches this time. Now let's again redo the analysis and check for deflection if this is going to pass in terms of deflection. So the way to solve deflection failure is to increase the depth of the slab. You can see already I had used a depth of 200, which is sufficient. So if the slab fails in deflection, it means that the depth is not sufficient. So a depth of 200 millimeters or 8 inches was okay. Now let's check if this depth of 6 or 150 millimeters, 6 inches or 150 millimeters is okay in terms of deflection. Now we're going to check the critical panel and also the maximum point of deflection where we just saw. Of course, in slab design, we design for the most critical panel. It basically means the largest panel. Okay, so let's check if this is going to pass in deflection. Now I need to display deformed shape combination. I need to display for long term. Apply, close. You can see this one is not okay at all in terms of deflection. So if you construct this house with that depth, this is about 6.2, this is about 4, it's the most critical panel. It has failed. All right, you need to check deflection because our maximum deflection is 18 millimeter and the permissible value is about 12 millimeter. So you need to increase the depth of this. So let's check. This 18 I think is at this point. Let's check at this point is 14. So this one is failing in terms of deflection. The rest of the panels are passing in deflection, but the most critical panel is even this panel is critical, is failing in deflection because 12.8 millimeters is more than around 12.4 is more than the maximum value, the permissible value. So the permissible value is usually Ly over 500 as per ACI code. So thanks for watching this video. If you like this video, please consider to subscribe to my channel. I will see you in my next video.